Okay, your last section in Chapter 7 on multiplying and dividing polynomials, 10.3 actually, it should say, or no, 7.3, not 10, so it's 7.3, is called Dividing Polynomials. So the first show you have a question like this. And the thing you need to understand is that division and multiplication of polynomials is very similar. If this question were a multiplication, like this, we know that each of these terms inside the bracket has to be multiplied by 3x. So we would have, if this was the question, we would have 45x cubed minus 36x squared, because we would know we would multiply all the terms in brackets by that 3x. The same thing is true when we have division. Each term must be divided by that 3x. Okay, so when we have, in this case, a binomial divided by a monomial, we want to use distributive property of division, and we want to rewrite this as, this is going to be the same thing as 15x squared divided by 3x, and negative 12x, notice how the subtraction sign became the negative coefficient, divided by 3x. And we're simply going to simplify both of those using division. So in this case, 15 divided by 3 is going to be 5 over 1, so I'm just going to have 5. X times x over x is going to become 1x. So if I divide 15x squared by 3x, I'm going to get a 5x. And again, if you have difficulty with dividing a monomial by a monomial, refer back to 7.1. We explored the division of a monomial by a monomial in that chapter. And here we're going to have negative 12 over 3, which has become negative 4. X divided by x is going to make 1 or nothing, because multiplying it by 1 does not affect it. And when I do that, I'm going to end up with these two terms, which I squeeze together. And the simplification for that will be 5x minus 4. Okay, so the answer to this, what is 15x squared minus 12x divided by 3x? The answer is 5x minus 4. In the second show, you have this question. Okay, you have 2t squared plus 4t divided by 2t. And again, because we're dividing a binomial by a monomial, we can use this idea of distributive property of division. I'm going to rewrite it as being this term divided by 2t and this term divided by 2t. And I'm going to simplify both terms. In this case, negative 2 over 2 is going to become a negative 1. I'm just going to leave it as well, I'll put negative 1 right now. It's okay. A t squared over t is going to become a t, so I'm going to have negative 1t or just negative t. We don't need a 1 coefficient. 4 over 2 is going to become 2 over 1, and t over t is going to cancel each other out. I'm just going to be left with 2 or a positive 2, in which case that will be the solution to what is negative 2t squared plus 4t divided by 2t. The solution is it's negative t plus 2. Okay, the next show which I've done backwards, I realize that now, but that's okay, is to solve the modeling of polynomials or solve the division of polynomials by modeling. In this case, if I was to interpret what this says, inside this area, I have a 2x as my length. I don't know my length, but I know the area inside is 6x squared minus 6x. Now my job is to determine what is the length that gave me this. So really, and effectively, if I know the area divided by one side that I know, it will tell me the other side. And we can use a simpler question to understand. If I took a rectangle and said the area was 10 and the width was 2, I would be able to determine that the length is 5 by taking the area, which is 10, dividing it by 2 to determine the missing side. The same thing is true with polynomials. I can take the area, in which case is this large binomial, 6x squared minus 6x, divided by the side I know. So it would be 6x squared minus 6x, the area, divided by the side I know, will tell me the missing side. So all we have to do is look at the picture and interpret what it is. Since this is a positive x right here, and I don't know this, but I know that this is a positive x squared, then this one here had to be a positive x as well, because a positive x times a positive x is a positive x squared, as well as all of these up here. Those are also x's. And then here I have a positive x, and I ended up with a negative x. So each of these has to be negative ones, because a positive times a negative is the only way I can get a negative x. So therefore, when I look at that missing side length pictorially, I see that that missing side length is 3x's minus 3. So the solution is, what is 6x squared minus 6x divided by 2x? The answer is, it is 3x minus 3. And again, if you solve it, if you work it out the same way as we did in the second show, you will find you get the same answer that way as well. In the second show, okay, thanks to my grade 9 class for letting me do that whole question that was already done for you. But this is actually, this first show, A. And it says 3x squared plus 6x divided by 3x. So the first thing I modeled when I set it up, I'm going to draw the first side I know. In this case, it was 3x, which is right here. And then I'm going to figure out, how am I going to put 3x squareds and a plus 6x in there? And I determined this is the way I fit it in. So when I drew my picture, that's what I get. And then to figure out the answer, all I have to do is determine what are the, come on now, you erase this now. There we go. What is the missing side length? So this is a positive x squared, this is a positive x, which means this has to be a positive x up here. This is a positive x and a positive x here. So these both have to be positive 1s. So therefore, my missing side length is x plus 2. Or, to paraphrase that again, the original question was 3x squared plus 6x divided by the side I know. Tells me the side I'm missing is simply x plus 2. And we can see that if we look at it, that's what it would work out to be. Especially if I use this idea of distributive property. I'd still get that x plus 2. In the second show, so here we have our model, and the question says 8x squared minus 2x divided by 2x. So the first thing I'm going to draw is the side I know. I'm going to put 2x's down here. They're positive, so I'm going to shade them in. Now I'm going to figure out, how am I going to fit 8x squareds into there? And I realize that the only way I can do that is to make, oh, I got to make this a little bit bigger. Bring this down here. Oh, not that. Hello. Ungroup. Take all this down, move her down here. I need to have 8 of them, so I'm going to put extend this just a little bit further, and I'm going to put a line straight across there. And now I have 8x squareds, and I need minus 2x, so I'm just going to put right there minus 2x. So I'm going to shade these in as positive 8x squareds. Those are all positive. And these negative 2x's are negative, so I'm not going to shade them in. And now all I have to do is figure out, what is the missing side from here. Since this is a positive x squared and a positive x, I know these are all going to be positives. So I'm going to shade those in. Those are positive x's. And over here I have a positive x multiplied by something to give me a negative x, so I know that has to be a negative 1. That's the only way I could do it. So therefore, I have interpreted the missing side length to be 4x's, not 3x's, but 4x's, minus 1. Not an x, but minus a 1. So therefore, what is 8x squared minus 2x divided by 2x? The answer is 4x minus 1. And again, if you wanted to check your answer to make sure it's right, you could use this idea of distributive property of division, and you would still see that it gets the same answer, 4x minus 1.